Hi guys, my name's Uti and today I'll be taking you through counting rules and probability. So the first thing is that a lot of people get confused between permutations and combinations and what you're supposed to do on your calculator, what you're supposed to do when you see a question that's asking you to calculate something. So what you have to remember is a permutation is a selection of items where the ordering is important. So if you're trying to find, let's say, the digits for a serial number for a bicycle, let's say, and you've forgotten them, the order of the numbers is important because there's only one order of numbers that will give you the exact serial number. But a combination is a selection of particular items where the ordering is not important. So if you have three people running a race and one finishes first, second, and third, you can choose from those 50 runners, you can choose that combination any way you like, depending on who wins the race. So we're going to be going through question 4 and 5 of a classwork that we actually did for one of our tutorials. So the first question reads, a local society is conducting a raffle where 50 tickets are to be sold, one per customer. There are 3 prizes to be awarded. If the 4 organizers of the raffle each buy 1 ticket, in how many ways can the organizers win all of the prizes? So in a question like this, first, we're going to start by finding out the probability of 3 people winning the tickets from the 50 people. So we're going to go 50, choose 3. And this will just give us a basis for the rest of the question. You'll be able to see later. But it's going to be 50, choose 3. And that's 19,600. So there are 19,600 different ways you can choose 3 winners from a group of 50 people. So now with the first question, it says, how can the organizers win all of the prizes? So there are 4 prizes to be won. There are 3 prizes to be won, but there are 4 organizers. So one organizer isn't going to win a prize in this case. So we're going to go 4 for the 4 organizers. Then we're going to choose 3 of them. And that's going to give us the number of different ways that the 4 different organizers can win each of the 3 prizes. Could somebody calculate that for me?
Calculating 4 choose.
4 choose 3, yeah. It's 4. So then there are 4 different ways to choose from the 4 organizers how they can each win 3 of the prizes. Now this is where the ways versus the probability comes in, because if they ask you how many different ways can so and so many people do something, then it's just 4 choose 3, right? But then if they asked us the probability, we would have to go 4 over the probability of 50, everybody winning 3 of the prizes. So then if they asked us the probability, it would be 4 over 50 choose 3, or 4 over 19,600. And that would be the probability if they asked us that in that situation. So then moving on to question B. Yes.
Can I please clarify something?
Sure.
You know how when you were introducing the difference between permutation and combination?
Over here, yeah.
Yes, yeah. So I liked your permutation example because it was sort of giving a sense of what does order matters mean, right? And then when you were giving the combination example, I actually thought it might be tricky to identify in that situation, because I think you made an example of
runners in a race,
right? Okay. So if we are all running and we want to know the top 3 people who are running, if we are not interested in position 1, 2, 3, then it's a combination. Like the example you just did now.
Yes.
We want the organizers, the 3 organizers to win. We're not interested in who's going to get first prize, second prize, or third prize, right? Then it's a combination. But if, for example, in the running example, the positions in which people are winning is important, then it moves from being a combination to being a
permutation.
permutation. So we just have to be careful there that, yes, there's 3 winners in the running. If we're just interested in 3 people winning, then it's fine. But if, for example, it says number 1 is going to get X amount of a prize, number 2 is going to get something less, and number etc., then order in that case matters.
Yeah.
Then we'd have to move back to permutation. Yeah.
No problem. And if you get confused with the example that I gave when I was talking about this, you can always just use the question example because it's a lot easier to understand, like Tina said.
Ask a question. When does this thing where you say 50 minus 4 and then you have 46 people left, then you choose happen?
We're going on to question B. It's question B.
Yeah.
So now, like she just asked, when are you going to have a case where you're going to have to minus and plus things and it gets a bit more complicated? So that's the next question. So there are still 3 prizes to be awarded, right? And we still have 4 organizers that we're trying to focus on. But question B is asking, how can they win exactly 2 of the prizes? So if they're winning 2 of the prizes, it means that everybody else is also winning another 1 of the prizes, right?
Mm-hmm.
So then out of the group of 50 people, our organizers are 4. So it's going to be 4, and we're just going to focus on the top for now. So it's going to be 4, and then out of this group of 50, there are going to be 46 other people, right? So then now we want them to win exactly only 2. So it's going to be 4, choose 2, and then 46, choose 1.
Mm-hmm.
And it makes sense because now 46 plus 4 is equal to 50, and then 2 plus 1 is equal to 3. So we still have the same number, except now we're just splitting it amongst the people, if that makes sense.
Okay, so the reason you're minusing all 4 is because the managers, it's already like taken those 4 managers, and so we're going to choose 2.
Yeah, 2 for them.
So
Because
it's already gone.
Yeah, because like I said, since we only want them to win 2, everybody else is going to have to get that extra 1. Somebody in that pool of 46 people is going to have to get that 1 other prize. So that's why we have to split it. And then it's literally the exact same thing. Like, could somebody just work this out? And you have to multiply these 2, if that's not obvious.
So 4 choose 2 is 6.
Okay, so then it would be 6 times
46.
46. And then 276. So then that's 276. And 276, that's the number of ways that this combination can happen where the 2 managers win the 2 prizes, and then the 46 other people win 1 of the prizes. But again, if they ask you for the probability, all you have to do is go 276 over 50 choose 3, or 276 over 19,600. You can do whichever way you feel comfortable with. Like, it's just that in the book you might see it done this way, and then you might not understand why I'm putting it over 19,600. But just remember that this is just that calculated, if that makes sense. So then now we're gonna move on to question number 5, and it reads, a student prepares for an exam by studying a list of 10 problems. She can solve 6 of them. For the exam, the lecturer selects 5 problems at random from the 10 on the list given to the students. What is the probability that the student can solve all 5 problems on the exam? Okay, so this one is a bit different now. So now, this one is just, they're asking you just for the probability. Because it says, what is the probability that the student can solve all 5 problems on the exam? So you won't even bother with just putting the ways down. You're just going to go straight to this step here. So now the student has learned 6 of the problems. So out of the possible ones that she knows, out of the ones that we want, she only has 6, right?
Mm-hmm.
So then 6, we're going to choose 5 out of that. If they had asked us how many ways can she answer the exam, then this would have been fine. but now they're asking for the probability. So the teacher said 10 problems in total, but they're only going to ask 5 of them. So now we're going to put all of this 10 over 5. And the way that I like to think of it is like it's what we want over what we don't want. So what we want is out of the 6 that we've learned, we want 5 of them to come up. But what we don't want is out of the 10 of them, we don't want any 5 random ones to come up. So we're just accounting for the other ones at the bottom because they may come up. So then now, if we calculate that, that's going to give us the probability of the student being able to solve all 5 problems. Yeah. So good.
Just to clarify, if I understand, so when we're talking about probability versus ways, when we're talking about probability, we're looking at the ways that we're interested in over like every
possible outcome. That's why I was saying like that's how I understand it, of like what we really want is the 6, and we're on 5 of those questions over everything that can possibly happen, which is 10, and it could be any 5 random questions out of the 10. Yeah.
Thank you.
Okay, just for the solution for question number 5, so it was 6 choose 5 all over 10 choose 5. And just to reiterate, the reason why we're doing this is because this is what we want. Out of the 6 questions, we want them to pick 5 of them. But out of the total possibilities of 10 questions, they can pick any random 5 which they want. So we're accounting for the other 5 questions which could come up because we're calculating a probability. So then the answer to that is, could you just find the answer for me, please?
0.0238.
0.0238. Okay, so that's the answer for that question. And then an example of a question where a permutation is involved. We're just gonna take it from the textbook. Example 3.9 on page 48. So a lot of the popular permutation questions involve either words or books or bank codes or serial numbers, because the specific order of what you're trying to find is really important to having the right thing. Because let's say you want to create a word like ant, which has 3 letters. The 3 letters, if you don't get those 3 letters in the correct order, it's going to spell a different word. So that's obviously a permutation. So any question in an exam or test where if the order is changed, something different will happen, then you know it's a permutation. So then here, the word is committee, and it has 9 letters, okay? So the word is committee. And this has 1, 2, 3, 4, 5, 6, 7, 8. There's an extra T. 8, 9 letters. Okay? So the thing that you have to look out for with a word permutation like this is that there's lots of letters that aren't distinct. There are a lot of repeated letters. So now we have to account for those when we're calculating the probability of when we're trying to find the number of permutations of this word. So basically, like we had here, we're taking the whole thing, or the number of ways that you can calculate this letter, and then we're going to find take the total number of repeated letters and put that underneath as the denominator. So then now the word committee has 9 letters, so there are 9 different ways you can order this word, but it has quite a few repeated letters. So it's got 1 factorial here, which is just 1, another 1 factorial for the second letter, so that's just another 1. Then we have 2 here, 2 repeated m's, so that's 2 factorial. Okay, the I is by itself, so that's 1 factorial. We have 2 repeated t's, so that's another 2 factorial. and then we have another 2 repeated e's, so that's another 2 factorial. And then this is the number of permutations for this word. That's the number of different ways you can order this word to find and get the letter committee. And the answer to the different number of ways is 45,360. And those are the number of different ways you can permit to find the word committee. Yeah. So, yeah, thank you.